notebook at the top. Write comparing decimals. Now the last time in here we talked about, you don't need to write this because you may have already written this in your notebook, but typically with base 10 blocks, you have that, you have that, and then you're going to have these. And then you're going to have those. And it depends what the whole number, which base 10 block represents the whole number, that will determine what the other ones represent. If this represents the ones, then this would represent the tenths, because it takes 10 of these to equal one of these. If this is the ones and these are the tenths, then this would be the hundredths. Because once again, it would take 100 of these to equal one of those. And then this little one down here would represent the thousandths. Because it would take 1,000 of these little ones to equal one of the whole ones. If this represents the tenths, then this one would be the hundredths. And then this would be the and then this would be the 10,000. So like I said, it all depends on what the whole number represents. It's possible that this could represent the ones. If this represents the ones, this would represent the tens. If this is the one, this would be the tenths. Because it would take 10 of these to equal one of these. If this is the one, these are the tenths, then this single one down here would be the hundredth. Because, once again, it takes 100 of these to equal one of them. It's possible that this could equal the ones. If this equals the ones, this would be the tens. And then this would be the hundreds. Because there would be 10 of these in this one, there'd be 100 of these in this one. If this is the ones, this would be the tenths. Because it would take 10 of these to equal one of these. And then it is also possible for this little one down here to be the ones. If that's the ones, this would be the tens, and then the hundreds, and then the thousands.
Should we write that?
You don't need to, because you already have it in your book. Okay? So, when comparing decimals, the first thing we need to do is basically, we're going to figure out, if we're looking at base 10 blocks, what base 10 block represents the ones place or the whole numbers. So when we're comparing decimals, the first thing we're going to do is compare the whole numbers. If the whole numbers are different, we don't even need to worry about looking at the decimals. Okay, for example, if we have 26 and 9/10, and we have 28 and 2/10. If we compare the whole numbers, we're going to compare the 26 to the 28. Well, obviously, which is bigger, 26 or 28? 28. And so the 26 and 9/10 would be smaller than the 28 and the 2/10. Because, once again, the 26 is smaller than the 28. The next thing, if whole numbers are the same, compare the 10. For example, bless you. We first compare the whole numbers. They're the same. So now we're going to compare the tenths. We have a 4 and an 8. Which one's bigger, the 4 or the 8? Obviously, the 8. And so because the 4 is smaller than the 8, the 16 and 4200 is less than the 16 and 8300. Now, where you get in trouble is this. Absolutely. If we have these two numbers that we're comparing, 23 and 308,000, 23 and 510. When you look at that, which decimal looks like it would be bigger? Or which number looks like it would be bigger? Kelton?
23 and 308.
A lot of people would make the mistake and say that 23 and 308,000 is greater than 23 and 510. But if we follow our rules, you first compare the whole numbers. They're the same. Then you compare the 10. You have a 3 and a 5. Which one's bigger, the 3 or the 5? The 5. And so since the 5 is bigger, the 23 and 308,000 is less than 23 and 510. Because, as I said before about working with the equivalent decimals, we can add or take away zeros as long as it does not change the place value of the other digit. I can add those two zeros there. And now this 23 and 5/10 becomes 23 and 500,000. Well, 500,000, that's more than 308,000, right? Okay? So because if we take it out to the thousandth place, 500,000 is more than 308,000, that proves it once again that this one is bigger. Do we need to do that? No, we can stop because in our mind, we know equivalent decimals, and we know that 3 is smaller than the 5. Okay? Rule 3. If whole numbers and tenths are the same, now we're going to compare the hundredths.
You put in tenths the same.
I know, I'm just kind of like writing briefly. If whole number and tenths are the same, keep in mind these are just notes, and so I'm not writing in complete sentences. I'm trying to get the idea down with as few words as possible. Okay, so for example, if we have 9 and 2700, 9 and 2300. The first thing we always compare are the whole numbers. The 9 and the 9, the numbers to the left of the decimal. They are the same. So since the whole numbers are the same, we go to the 10. 2 and a 2. They are the same. So now we go to the 1,000. We have a 7 and a 3. The 7 is bigger, and so because of that, 9 and 2700 is greater than 9 and 2300.
So it's basically you're just moving one spot over every time, like you're
If they're the same.
So like you would start at 2s for both of them. Wait, you start at the 9s, so the 9s are equal.
Well, you start at the whole numbers, okay? We're comparing everything to the left of the decimal.
Okay. So that would be 2 with 2, that would be equaling this, that would be 0. But then the 7 would be bigger than the 3, so it would be 9 and 27.
Let's do this one. $12 and 3400. Oops. $12 and 3400 compared to 12 and 329 thousandths. Once again, the first thing we do is we compare the whole numbers. 12 and 12, they're the same. Now we go to the 10. 3 and 3, they're the same. Now we go to the hundredths. We have a 4 and 2. They're not the same. Since the 4 is bigger than the 2, we would know that 12 and 3400 is greater than 12 and 329 thousandths. Once again, the reasoning is, if we want to, we can put a 0 here in the thousandth place. Still means the same because we can add or take away zeros as long as it does not change the place value of the other digits. By adding that 0 there, everything else stayed the same relationship to the decimal, and now you have 340,000 compared to 329,000. Yes?
If you say that like 12 and 32 hundredths and
329? Oh, you mean just stopping at the 3200?
yeah, and the other one was bigger, but
Same basic idea.
like the other one was less. Oh, so
If they're different,
32 and then 12 and 32 9. So like it ends.
Oh, what you're saying, okay, okay. So, this example, 12 and 270, or 2700, 12 and 276,000, that.
Yeah.
Okay. How about this one instead? Let me go back to this one.
Can we write this?
Yeah, you can. 12 and 210, 12 and 2700. How about this, Addie? And then we're going to get to that question in the next one. Whole numbers are the same. Tenth are the same. So now we go to the hundredth. Here you have a 7. Here you have a nothing. What's bigger, 7 or nothing? 7. Okay. So there is nothing there, but we can put a 0 here. And now you have a 0 compared to a 7. Okay? And so the 12 and 2/10 would be less than 12 and 2700 because here you have a 7 in the hundredth place, here you have nothing. And then rule 4. And it follows the same pattern. If whole number, tenths, and hundredths the same, compare thousands. For example, 6 and 727,000 compared to 6 and 729,000. Once again, the whole numbers are the same, so we compare the tenth. The tenth are the same, so we go to the hundredths. The hundredths are the same, so we compare the thousands. We have a 7 and a 9. The 7 is smaller, and so 6 and 727,000 would be less than 6 and 729,000.
Could there be an answer equal to?
Absolutely.
I was thinking the same thing.
Yep, absolutely. If we have this, 5 and something like that. 5 and 349,000 compared to 5 and 34,692 hundred thousandths. First, compare the whole numbers, they're the same. Compare the tenth, they're the same. Compare the hundredth, they're the same. Compare the thousandth, we have a 9 and a 6. That's where the first place where there's a difference. Since the 9 is bigger than the 6, 349,000, 5 and 349,000 would be larger. What we could do, just to make a look to prove it, we can add these zeros here because it doesn't change the place value of the other digits. Now both of them go to the 100,000th place. Here we have 34,900 hundred thousandths. And here we have 34 and 692 hundred thousandths. Well, 34,900 is more than 34,692. Now to go to adding example, if we have 3 and 2400 compared to 3 and 247,000. The whole numbers are the same. The tenths are the same. The hundredths are the same. When we go to the thousands, we have a 7, we have nothing. Well, 7 is bigger than nothing. And so since 7 is bigger than nothing, the 3 and 2400 is less than 3 and 247,000. If you wanted to prove it, put that 0 there because it doesn't change the place value of the other digits. And so, since the 3s are the whole numbers are the same, 240,000 is less than 247,000. Keegan.
Are we allowed to bring our notebooks home?
Absolutely, they're yours. I mean, the reason we do this is so that when you go home,
Now, like for when we're in 6th grade next year, would we, and if we still have you,
add on to it.
yeah, oh, okay.
Okay? Questions about this? Okay, let's get your whiteboards out.
My whiteboard's not in, but my eraser's not in.
We have to use your
That might have been it.
Okay? Write those two numbers down and compare them. Okay, what's the first thing we're going to compare? Add the whole numbers. So we compare the whole numbers. 12 and 13. Are they the same?
No.
Nope. 13's bigger, and so 12 and 364,000 would be less than 13 and 9/10. So the first thing you always want to compare is the whole numbers, or the whole numbers. Write these two numbers down. Okay, so the first thing we compare are the whole numbers, they're the same. Now we compare the 10th. You have a 0 and a 7, the 0 is smaller. And so 6 and 234 10,000 is less than 6 and 7 10. Erase it. Write those two numbers and compare them.
Should we write? Oh, so we do write down the numbers.
Yeah, write them down. I see see some people that are underlining what place value tells the difference. That is a great thing because later on in your homework assignment tonight, they're going to ask that. You first compare the whole numbers, they're the same. You compare the tenth, they are the same. You compare the hundredth, you have a 0 and a 1. The 0 is smaller, and so 5 and 1,011 10,000 is less than 5 and 110 thousandths. Write those two numbers down. Compare them. You guys can't be correct so far. Good. Okay, something like that is usually one, if you're going to get tricked up, something like that's usually where you get tricked up. If you first compare the whole numbers, they're the same. You compare the tenth, a 1 and a 0. The 1 is bigger than the 0. So 6 and 9,000 is less than 6 and 1/10. Okay? Questions about these? Now, something they're going to ask you is to identify the place value that tells you which one is bigger or smaller. In this example here, which place value told us which one was bigger or smaller? Keegan?
The base or the...
What place value? Camden?
The whole... No,
What particular place value?
the...
Hilton?
The tens.
Alexa? The ones. Okay? In this one, what place value told us which one was different, which one was bigger? Thad?
The tens.
The tenth. In this one, which place value told you which one was bigger? Trent?
Hundreds.
In this one, which place value told you which one was bigger? Jasmine?
Tens.
Okay? And so they're going to ask you to identify what place value tells you which one is bigger or smaller. Okay? Questions about that? So, part of your assignment is going to be to compare them. Part of your assignment is going to be ask what place value tells you which one is bigger or smaller. Now, another thing they're going to have for your homework is they're going to give you a number line. And they're going to ask you, they're going to give you some numbers. Out of those four, they're going to ask you which numbers are to the left of 6 and 7 10. Now, on a number line, the left means smaller, to the right means bigger. And so they're going to ask you which ones are smaller than 6 and 7 10. Is 6 and 7300 smaller?
No.
Now, this one, I'll say this is A. This one would go just slightly to the right of it. So that one now. What about the 6 and 279 thousandths? Would that go to the left of 6 and 7 10?
Yes.
Yes, because the 2 is smaller than the 7, so the 6 in 279,000, 6.4, 6.3, 6.2. B would be located somewhere about there. Because 6 and 279,000, that is between 6 and 2/10 and 6 and 3/10. So it's somewhere in between there. So this one is a good one. That would go to the left of it. What about 6 and 8/10? Would that go to the left or right?
Right.
It would go to the right because that would be located right there. What about 6 and 42/100? Would that go to the left or right?
Yes.
Left or right?
Left.
Left. Where would that number go on our number line?
Right.
Between which ones? Alexa.
6.4 and 6.5?
It would go between 6.4 and 6.5. It's smaller, it's bigger than this, but smaller than that. And so letter D would go somewhere about there on your number line. And so like I said, they're gonna give you some choices and they're gonna ask you which ones go to the left of a certain number or which ones go to the right, meaning bigger. Okay? Keep in mind, left is smaller, right is bigger. Okay, should we do another one of them?
Nah.
You guys comfortable with that?
Yeah. We got it.
Okay? Once again, it's just the same thing as comparing numbers. So you're going to have something like that. Just looking at your homework so there's no surprises. Comparing, comparing, comparing. The last type of problem they're going to give you is this. Okay? And they're going to ask you, how would you write that number, this digit, in expanded form? Well, what place value is the 7 in?
100.
So, you could put it as this, or that, or that. Okay?
Can you also put it like this? Yes or no? But that kind of
Aren't
just
you?
relates to that one.
Yeah,
I'm thinking the same
I'd like it
thing.
to be like this.
Okay.
Oh.
End of the world.
Oh, no.
Okay? So, really you're going to have 4 types of questions for homework tonight. First one, just simply comparing. Second one, they're going to say, pick the number that's either to the left or to the right of another number on a number line. Keep in mind, left is smaller, right is bigger. They're going to ask you to put this, they're going to give you a number or a digit and tell you, based on what the number is, what place value's in, to write it in expanded form. And then they're going to also tell you to write this entire number in expanded form. If you don't write that number in expanded form, you would have 20 or 2 times 10 plus 4 or 4 times 1 plus 3/10 or 3 times 1/10 or 3 times 100 or 1 over 10, 700 or 7 times 100th or 7 times 100th as a fraction, and so on. Okay? Any questions? Okay, your homework. I want you to do 3 to 12. And then also number 16. So 3 to 12, all of them. And then number 16. Go ahead.